Good morning. In today's session, we are supposed to solve some numericals. So here we were studying our fourth unit, that is nothing but three-phase induction motor, in which we have seen we can call induction motor as a electromechanical energy converter because it is using the electrical energy and it is converting that energy in the any form of the mechanical form. It means what? Here we can convert electrical energy into the mechanical energy. So we are calling that as a synchronous induction motor. Then we have seen there are different types of induction motor like single phase and three phase depending on how we are giving the power supply to the three phase induction motor. But in our syllabus only we are supposed to study about the three phase induction motor. There are two types of three phase induction motor. These are nothing but slip ring induction motor and the squirrel cage induction motor. So if we are using the slip rings on the same shaft where we are using the rotor and we are using at the both end we are using the bearings, at that time we are calling that as a slip ring or the wound induction motor, and we can use the slip ring induction motor where we will require sorry where we will require higher starting torque. Then we have seen about the squirrel gauge. So if we are not required higher starting torque, at that time we can use the squirrel gauge. Then we have seen about the speed control method of the three-phase induction motor. So we have seen for that we will relate the torque equations and how the torque will related with the rotor reactors, rotor resistors, slip, all these things already we have seen. So here we are supposed to solve some numericals. For that, we have seen the different equations. Like we have seen equations for the synchronous speed. Synchronous speed we are denoting by capital N suffix S. We are denoting by capital N suffix S, and we can calculate mathematically synchronous speed as 120 F upon P. F is nothing but the frequency of the induction motor and P is the number of pole. Then we have seen how slip will be related with the synchronous speed and the rotor speed. Rotor speed we are denoting by capital N. So we can calculate S equal to Ns minus N upon Ns. Then we have seen about the equation for the torque. How will you get? You will get torque equal to constant term K into S into E2 square upon R2 square plus S X2 square. So we have already seen these things. Now we are supposed to solve some MCQs. So there is question like the slip ring or the wound rotor induction motor. Find its application in. So as we guys are aware about slip ring, we can use where we will require higher starting torque. And if you talk about the lifts and cranes, that will require higher starting torque. So we can say that will be the correct answer because higher braking torque can be obtained if slip value is greater than unity. And its application is we will require in the lift and cranes higher starting and braking torque. So we can use slip ring in the lift and crane. If there is a question like slip speed of motor devices, the motor decides the magnitude of induction, induced EMF and the rotor current, which in turn decides the torque produced. If Ns is the synchronous speed and N is the rotor speed. If they are not giving at that time also, we are taking the same thing, Ns for the synchronous and N for the rotor speed. They have given here motor speed, but you can say motor or the rotor speed because we are aware about the construction of motor. Motor main parts are nothing but rotor and the stator. Stator is stationary, so speed only will come for the rotor. So you can say N as the motor speed or a rotor speed. There will be no difference. So then slip is given by. Already we have seen the equations. How will you get? If we are calculating the slip, only slip, we can calculate Ns minus N upon Ns. But there is question, the slip speed. Slip speed. So slip speed we are calculating by Ns minus N because we are taking slip speed as the difference between the synchronous speed and the actual speed or the speed of induction motor. So we can take its sleep speed as a ns minus n. Now, there is a question like at the start, slip of induction motor. We are we have seen we will get higher slip, but when there is a maximum speed, and at start speed of motor will be 0. You can calculate here. If we are taking that 0, you will get ns by ns. So you will get slip as a 1. So you can say you will get slip equal to 1 when we are taking it as a maximum. And if we are taking at higher speed, slip will become 0. There will be definitely question will come on that slip of induction motor. Sometimes they will give for starting, and sometimes they will give slip of the induction motor at highest speed, at the maximum speed. At that time, that value is 0. And at start, slip value is 1. If you are not getting that point, you can cross check your answer with these equations, because we have seen the slip equal to ns minus n upon ns. We are supposed to take at start. At start, rotor will not rotate. So speed of the rotor will become 0. So if we are putting at 0, you will get s equal to ns by ns. So you will get s equal to 1. So we can say at start, slip of induction motor will become 1. Now, स्ट्रेंथ कम हो गया है क्लास का काफी. Okay. So here. Now, there is question like a 50 hertz three-phase slip-ring induction motor has 6 poles on the stator and 4 poles on the rotor. Then machine will be at. See here what they have given. The poles of rotor and poles of stator are different. You can see here. They have given here. Stator will have 6 poles, rotor will have 4 poles. And if they have different poles, resultant torque will become 0. And as torque will become 0, machine will not run. So we can directly say machine will not run. You guys will get confused, because if they are giving here 4 poles, how you will calculate? You can directly calculate ns equal to 120 f upon p, 120 into 50 upon 4. If you solve, you will get 1500. And if you are solving 120 into 6 upon 120 into 50 upon 6, if you solve, you will get another answer. Like that, if you are solving, you will get confused. But if they are giving the different poles, if they are giving the same poles, at that time you will get one of these 3 answers. But what they have given, they are giving us the induction motor in which stator and rotor are having the different poles. So we can say if they are having the different poles, they are not equal, then resultant torque will become the 0 and motor will not run. Okay. So here another question. Nature of the rotor power factor. Nature of the power factor in the running condition is always, if they are asking in any condition, what we have seen, we are having the rotor factor, that will be the lagging. Just in yesterday's session, there was the EEE paper for the 2015. At that time also, the question was there. The rotor power factor in running condition is they have just changed the statement, but what you should need it, the power factor in the 3-phase induction motor will be lagging. So we can say here the power factor of induction motor is always, if they are giving running condition or any conditions, there will be no difference, because it will be always lagging. क्योंकि कल के जो पेपर में क्वेश्चन था, at that time they have not given there like a running. They have given only the power factor of the 3-phase induction motor will be 1, will be 90, will be leading or the lagging. At that time you are supposed to understand it will always be lagging. These questions are very much necessary, because in this PDF lots of questions are fabulous, means बहुत अच्छे questions है. All these questions if you will study now, you will get the full marks in our test also. I am not taking the same questions. I have already make your unit test, but the questions, the pattern will be like this. You will require these equations, you will require these theories, how the speed of rotor of the induction motor will always less than synchronous speed, where you will get the slip value maximum, where you will get the slip value minimum. Minimum means what? You will get slip value 0 and maximum means you will get the slip value 1. When at the start of any induction motor, you will start at that time, at start you will get slip equal to 1. Like that you will be needed this. So here there is a question like, if a voltmeter when connected to the rotor of induction motor, it will gives 150 oscillations per minute and stator frequency is 50 hertz. Then the slip of induction motor will be. Now we are supposed to find the value of slip. How we can find? We are having the equation. Which equations? S equal to ns minus n upon ns. But here they have not given anything about the n. So we can see any other questions. Yeah, we are having. What is the equations we are having? We are having S equal to Fr. S equal to Fr upon F, because we are having rotor frequency equal to slip into the frequency of induction motor or the maximum frequency of the induction motor. What is that? We are having Fr equal to S into F, but we are supposed to find the S. So we can take Fr upon F. For that, F they have given here. This is the stator frequency. This is the frequency of the induction motor. You are supposed to find the rotor frequency. How we can calculate? We are having the equation Fr upon F. But for that Fr के लिए हमारे पास equation है. What equations we have get here? If you see, they have given here the oscillations. They have given here oscillations, and we are having 150 upon 60. If you solve, you will get that as a 250 hertz. Because see here, if you are solving that, you will get here the frequency, that is the 2.5 hertz, because they have given here, if a voltmeter when connected to the rotor of induction motor, it will give us 150 oscillations. So you can take number of oscillations here per minute. So frequency क्या होता है? Reciprocal of time. Reciprocal of time. So you can take here, they have given the time, so you can take 1 minute as 60 seconds, because we are calculating the frequency and we will need the frequency that will take the time that will be in the second. So we can take oscillations per minute time, 150 upon 60, you will get 2.5 hertz. So now you can take value of Fr, you can put the value of frequency of stator, they have given 50. If you solve, you will get 0.05, but they have given in the percent, so 0.05 into 100, you will get 5%. Sometimes they will confuse you, like they will give here 5%, 0.5%, 0.05%. If you are writing in a percent, you are supposed to multiply that answer with the 100. So you will get, that is the 5%. We can see the another question where they have given the nature of the graph in the low slip region and in the high slip region is. So already we have seen about the graph, how the torque will relations with the slip. So we can see here directly before this, you can see the waveform here, so you will get. If you see, it will be look like a straight line when you will get the slip value. What they have given? The nature of graph in the low slip. So if you see here, we are taking here slip equal to 0. We are taking here maximum slip. So from 0, low slip, you can see it will be look like a straight line, because it is looking like a linear. We are saying when we are taking the at start slip equal to 0, at that time you will get the value of torque will be increased linearly with increase in a slip. So you can say that will be straight line. So these are the two You can say for the first. Another, what they have given, and in the high slip region. So in high slip region, if you see here, actually, if you see, we are saying that will look like a decrease. But if you see, it will be as a rectangular hyperbola. So we can say in the slip region, torque is directly proportional to the slip. So if we are increasing the load, speed will decreases. And as speed will decreases, there will be increase in the slip. And this will increases the torque which will satisfy the load demand. So in the first, in the low slip region, you will get the straight line. But in the high slip region, torque is inversely proportional to the slip. यहाँ पे डायरेक्टली है, यहाँ पे इनवर्सली है. Hence, its nature will look like a rectangular hyperbola. Because if you see, it will be look like a hyperbola. So we are taking that as a rectangular hyperbola. Because if you see, they are giving here decaying exponential. They are not giving here about hyperbola. So we are supposed to select correct answer as a C. Now, there is a question like, if induction motor is operating at a point in high slip region. So just see the graph. High slip region. If we are talking about the low slip region, at that time you will get that as a stable. But if it is in the high torque, high slip region, at that time you will get that as unstable. So there is an answer. You are supposed to write the unstable because they have given the question. If induction motor is operating at a point in high slip region, then motor will be in unstable. And if they are giving induction motor is operating in the low slip region, at that time you are supposed to write the answer as a stable. So in high slip region, torque is inversely proportional with the slip. So torque will decreases as slip will increase. But torque must increases to satisfy the load demand. So as the torque decreases due to extra loading effect, speed further will decrease and slip will increase. So we can say as the speed will drop, at that time motor comes to standstill condition. And as we are saying, motor is not continue rotating. At that time we can say that region will called as unstable. Now there is question like the value of slip for motoring generating braking region. We have seen that. You will get, if you see at start, the range S equal to 0 to S equal to 1 is we are calling as a motoring. And if the S value is less than 0, we are calling that as a generating. But this concept we will not require, but there will be question on the numericals can come. Because you are supposed to only see about the motoring region, motoring concept. But you are supposed to understand when you will get generating region. So if the value of slip is less than 0. So if you see all these, only here you will get the braking region, generating region. And for the braking region, you will require slip equal to greater than. And about motoring, we have seen you will get slip equal to 0 or slip equal to 1. You can observe this waveform. See here, you will get slip equal to 0 or you will get slip equal to you can see here, if we are using that as a motoring region. So here you will get S equal to 0 or S equal to 1. So we can say for the motoring region, you will require slip equal to 0 or slip equal to 1. That will be in between that. And for the generating region, slip will be less than 1. And for the braking region, slip will be greater than. Now we can solve one numerical. There is question like a 16 pole, number of pole 16. 50 hertz star connected. We can give the power supply that will be as a star or a delta. Now there is question like star connected three-phase induction motor has rotor resistance. They have given here rotor resistance 0.012 ohm per phase and rotor reactance. Rotor resistance we are denoting by letter R2. Rotor reactance we are denoting by X2. 2 is for rotor, 1 is for stator. So here Ohm per phase at standstill. Its full load torque is at speed of 220 rpm. So here they have given the speed, full load speed, ratio of its starting torque to maximum torque. So we are having the equations for the starting torque and the maximum torque, because torque equation say, if you see, torque equation is depending on reactance, torque equation is depending on resistance, torque equation is depending on the slip. So here they have given slip is maximum, slip is maximum we are taking as a Sn, and it will be maximum at maximum. It will be maximum at maximum torque. So we can calculate slip, that will be equal to R2 upon X2. R2 they have given, X2 they have given. You can calculate. Now we are having the formula for the starting torque with the maximum torque. That is 2 into maximum slip upon 1 plus maximum slip square. This equation you will be needed to solve numericals if there is question on the ratio of starting and the maximum torque. If we have not seen that equations, you can note that equations, because you will be needed this also. So you can calculate slip as R2 upon X2. This we have already seen. And we are having starting torque upon maximum torque, that is the 2 into maximum slip upon 1 plus maximum slip. Maximum slip we can calculate. So if you solve this, you will get that ratio as 0.10867. So you can write 0.1087. That is the correct one. Now there is a question like the torque developed in the three-phase induction motor will depend on. We have seen how it is depend. It is depend on the flux. It is depend on the current. Which current? It is depend on the stator current. So we can say that will depend on the, it is depend on I2, because we are having the formula. Just wait. You can see here we are having the torque equations. What is the torque equations? Torque equal to K into S into E2 square. So E2 मतलब क्या है? रोटर का voltage. Please mute yourself. So you can see here what is the difference between stator and rotor current. We are supposed to understand, because we have seen the torque equations. Torque is directly proportional with S K E2 square upon R2 square plus X2 square. But here they have given about the flux. So that will depend on the stator flux, but it is depend on the rotor current, because it is depend on the E2 square. E2 मतलब रोटर का voltage, और रोटर का voltage क्या है? रोटर करंट पे डिपेंड रहेगा. So we can say it will be depend on rotor current and the stator flux. So we can say here torque of the three-phase induction motor is proportional to the flux, as well as it will depend on the rotor current and the power factor. But they have not given anything about the power factor, so no need to write. Again, if there is question like an induction motor when loaded from no load to full load, NL to FL, its slip also varies from maximum to minimum. Then torque in slip region and in high region, that will be as we have seen that how it is dependent. You can directly observe here. Torque is directly proportional here. When at the start, when we are taking S equal to 0, and when we are taking the maximum slip or the unstable region, we are taking the maximum at that time. It is inversely proportional. That's why we are calling that as a rectangular hyperbola. So there is question. So you are supposed to write it will be directly proportional to the slip when we are talking about the low slip region, and it will be inversely proportional to the slip when we are supposed to see about the high slip region. If you want to see, if you want to explain theoretically, you can explain like that, because we have seen the equations for the torque. You will get torque equal to S into E2 square R2 upon R2 square plus X2 square. If we are taking the things X2, K as a constant, we can directly keep T will proportional with S R2 upon R2 square. If we are taking resistance as a constant, we can take torque is directly proportional with the slip. So we can say in a slip region, in the low slip region, S is very small, and due to this we can neglect S into x2 square, which is come in the here. So we are taking that as a small and we are neglecting. So you will get torque will proportional with the S. And if we will talk about the high slip region, you will get torque will be depend on here SR2 upon SX2 square. So here if we are taking R2 square very small as compared to SX2 square, we can neglect R2 square. But we are supposed to consider that impedance, that reactance. So we can say torque will inversely proportional with this. So we will get here 1 by S, because here if we are taking R2 as a constant, R2 as a very small, सो ये S और ये R2 हम निग्लेक्ट करेंगे और हमें क्या मिलेगा टॉर्क का इक्वेशन इट विल डिपेंड ऑन दिस S square. So we can say it will be inversely proportional. You can see the another one. There is question like a 400 volt 4 pole 3 phase 50 hertz star connected induction motor has a rotor resistance and rotor reactance. If they are giving rotor resistance and rotor reactance, you are supposed to solve there as a maximum slip. Maximum slip is nothing but R2 upon X2. R2 they have given. What they have given? Resistance 0.02 and reactance 0.2. If you solve, you will get 0.1. You are supposed to write in percent into 100. You will get 10%. All these things they have given. 400 volt, 4 pole, 3 phase, 50 hertz. All these terms we have not needed because they have given only you are supposed to find the maximum slip. Maximum slip you will get when there is a maximum torque. And how you will get that slip is nothing but R2 upon X2. So you will get directly by using only these two values. Now, there is question like when torque produced by induction motor is maximum, slip is, what equations we are using? We are using maximum slip is nothing but R2 upon X2. So you are supposed to write that one R2 upon X2. If you want to solve, you can solve. How you can solve? We are having the torque equations. We are having the torque equations. What is the torque equations? K into S into R2 into E2 square upon R2 square plus S X2 square. U upon V. So you can take its derivative. And if we are taking that derivative will become 0. You can say you will get the maximum torque. We have, you guys are aware about the derivative. You have studied in the mathematics. So you are supposed to understand how we are taking the derivative of torque. How we are having the torque equation in the U by V form. So you can take U into dV by dt minus V into du by dt upon V square. If you solve like this and you are equating that with 0, you will get maximum torque. So if you solve, you will get S equal to R2 upon X2. So you can say you will get the maximum slip, that will be R2 upon X2. Now, stable operation of the induction motor can be expected between. Where we are expecting, we are taking that from 0 to S equal to Sm. That is nothing but at that point you will get the torque, that is the maximum torque. So you can say from 0 to maximum torque. As well as slip is also maximum. So you can say you will get the stable region of the induction motor that at a 0 to maximum torque slip. Because if you see the slip range from 0 to maximum slip is known as a stable region of the principle of operation of induction motor. So we can say motor always will operate at that point in this region, in the stable region from S equal to 0 to S equal to Sn, or from torque equal to 0 to torque equal to maximum. Sometimes that question will come for the torque, sometimes that question will come for the slip. So you can say from the for the torque 0 to maximum torque. Again there is question like the rotor of induction motor cannot be run with synchronous speed, because what we are saying, we are supposed to take always synchronous speed से rotor का जो speed होता है, how we are taking less than. So here there is question like the rotor of induction motor cannot run with synchronous speed because rotor torque will become zero. If we are taking an S equal to N and S equal to N, our slip equation is S equal to Ns minus N upon Ns. So if we are taking both as same, what you will become? You will get 0 upon Ns. So that value will be infinite. So what we can say, you are saying torque is directly proportional with the slip. But if we are taking the rotor speed is running at a synchronous speed, there will be no difference between the rotor speed and synchronous speed. So you will get slip will be equal to 0 because S equal to 0 upon Ns. So you can say that time you will get slip equal to 0. So there will be no torque and rotor will not move. Rotor will slow down. So we can say rotor torque is becoming 0. That's why we cannot take rotor speed that equal to synchronous. We are supposed to always take rotor speed less than synchronous speed. Now you are supposed to solve one numerical. A 6-pole, number of pole 6. Induction motor is running from 50 Hertz, frequency 50. And S you can solve 120 into 50 upon 6. If you solve, you will get 1000 RPM. The EMF in its rotor is, EMF is nothing but you are supposed to take EMF as a EMF as you can take as a voltage, but they are not given here about the EMF. The EMF in its rotor is of frequency. They are giving here the frequency, that is the 2.5 Hz. So that frequency will be the rotor frequency. This frequency is the frequency of induction motor F, and this is the FR because they have given the EMF in its rotor is of frequency. So FR is 2.5 Hz. And we are having the equation FR equal to S into F. So we can solve here for slip. We are having the value for FR. We are having the value for F. You can solve 2.5 upon 50. You will get 0.05. Now you are supposed to find the speed of motor. Sometimes they will give speed of motor. Sometimes they will give speed of rotor. You are supposed to solve N. We are having S equal to Ns minus N upon Ns. If you are moderating that equation, converting, you can write N equal to Ns 1 minus S. If you solve N equal to Ns, we will get 1000 into 1 minus S 0.05. If you solve, you will get 950 RPM. There is a C options where we will get 950. So you can take answers. You will get the answer. Now we will solve this question and then we will conclude our session. So here, for a 3-phase 50 Hertz squirrel gauge induction motor, if there is squirrel gauge, if there is slipping, we are having the same equation for the maximum slip, R2 upon X2. So they have given for 3-phase 50 Hertz squirrel gauge induction motor, leakage reactance at standstill is twice of its resistance. So if we are taking the resistance as R2, twice of R2, that will become X2. So you can take X2 as twice of R2. We are having the equation maximum slip equal to R2 upon X2. X2 की जगह you can write 2R2. R2 get cancelled, 1 by 2, 0.5. Maximum slip you will get 0.5. Now, the frequency of supply at which maximum torque is obtained. So here you are supposed to find the rotor frequency. Fr equal to S into F. S we have solved 0.5. F they have given 50. If you solve, you will get 25 hertz. This type of questions will also come in the unit test as well as in your theory paper. So if anyone is facing any issue regarding any numerical, if you are not getting, you can ask. I'm taking your attendance. Okay, so here we can conclude our session. Thank you.